the posterior pituitary. So we know that the pituitary gland has two lobes, one the anterior pituitary and the one is the posterior pituitary. You can see the diagram of the pituitary again here. So now we are going to discuss about the posterior pituitary. Now what we need to discuss are the hormones. There are two hormones that we will discuss in posterior pituitary, that is antidiuretic hormone and oxytocin. Let's first come to antidiuretic hormone. Now it is also known as vasopressin. Reason being, it constricts the blood vessels with rise in blood pressure. Vaso means blood vessel. So it is pressing the blood vessel. Pressing. So what happens if this is a blood vessel? I told you about vasoconstriction when I was teaching blood. You might have a fair knowledge about blood also, or vessels also, because that has been taught to you. But still I am showing you. This is the normal blood vessel. After that what happens is it undergoes vasoconstriction, means ADH acts, and after the acting of ADH, this blood vessel is pushed from both the sides like this, and finally what happens is the blood vessel constricts. So you can see the breadth of the blood vessel has decreased. Okay, the lumen is shorter. If it is the, now this is the horizon, this you can view the blood vessel from this side, and now if you take it in front, then if you see before applying ADH, the blood vessel was like this. The blood vessel was like this, and after application of the ADH, the blood vessel is like this. You can see here the lumen is wide, whereas here the lumen is very narrow. So what happens? Blood cannot flow easily through a narrow lumen blood vessel when there is constriction, and blood can easily flow through a wide lumen because there is more space. More amount of blood can flow, and here very less amount of blood can enter. What happens is that leads to a rise in the blood pressure, because if there is blood flowing through this, let me draw another diagram for you. Let's draw it here. If blood is flowing through this blood vessel in this way, I think it's easy to understand. Blood is not blue, but assume that this is blood flowing through. Okay. So is the blood stream going like this, and all the blood is flowing inside. Now what happens is there is constriction. The space becomes less. So when space becomes less, what happens? Very less space. Very less space. It has constricted a lot. So the blood cannot be easily passing through the blood vessel. Suppose I told you about a hose pipe concept, where I told you when I open the pipe, when I connect the pipe to the tap and I open the pipe, when I open the tap and the water moves to a pipe, you can do this experiment. Hold one portion of the pipe and stop the flow. Once you press the pipe, you will see that less amount of water will flow. The flow is going on, but less of the water can flow because you have constricted, you have pressed the part of the pipe. And what happens is that region where you press the pipe, the water flows very less from that point. So more pressure is created at the back of the place where you have pressed the pipe. So more pressure is developed. So blood pressure becomes more. As there is more blood is flowing like this, and if ADH presses it, and if the space becomes so less, so what happens is pressure starts to develop on the both of the sides. So why this happens? This is why there is a rise in the blood pressure. I think there cannot be any possible explanation. You have understood it. Normal blood flow is going on. I press the thing. Once I press the thing, this water or this blood becomes enclosed. It has less space to move. So less amount of blood can move in the same time. Less amount of blood can move in the same time. If in 1 second, if I am assuming 5 units of blood are moving in 1 minute in a normal. After ADH is being applied, after there is pressure, there is very less place to go forward. Here after the contraction by ADH, we'll observe in this blood vessel, in the second one, after ADH has constricted, has pressed the vasopressin, press the blood vessel, you will see 1 unit of blood moving in per minute. Unities can be in a unit. This is the thing. Now you can see here. See, you can see here, right? You can see that this is how a blood vessel, constricted blood vessel and normal blood vessel looks like. Vasoconstricted means constricted blood vessel and normally dilated blood vessel looks like. You can see the difference. Here you can also see that the horizontal cross section means you can see this type of a structure from this view as well as from front view. You can see both the diagrams. Okay, second you can see now. Yes, a small video for you. See how the blood is constricting, how the blood is flowing, and after dilation how the blood is. You can see the whole movement. You can see the whole mechanics. This is technology. First what I did, I taught you just like a teacher teaches you. Then technology. Now easy to understand. This is our mission. We'll make it so easy that you will play. Yes, this is a child's game. Everybody can understand. So second thing is, these antidiuretic hormones act on the kidney tubules and increase reabsorption of water. It's very important. In the kidney tubules, the ADH is acting. Once the ADH acts on the receptors present on the kidney tubule, because I said that it will, a hormone always goes to its target cells. And now ADH's target cells are present in the kidney tubules. So what happens? When they act on the kidney tubule, the collecting duct basically, first what was happening? Normally what happens, there is a regulation. Means if the body does not have much of water, then ADH gets stimulated. ADH gets stimulated. And once ADH is stimulated, ADH works on the kidney tubules. What are the kidney tubules? It is like this. You have seen. Bowman's capsule. I think I have talked about it in the excretory system. Then you have all these different types of things going on, and this PCT, DCT, all of them. And then finally you have collecting duct. And finally what happens? I am not drawing the complete structure. Don't think that sir is not drawing the. I am not drawing the complete structure. I am just trying to make you understand. And here the urine comes out. Okay. So this is Bowman's capsule and all these things, efferent arteriole. This is efferent arteriole and then and afferent arteriole. Little better diagram I hope. Okay. So blood is coming and then water is being and the filtrate is being absorbed and all these things are happening. Okay. See, this is coming down and all these things are happening. The filtrate is being taken and all these things, all different processes happen that you are not knowing in detail here. That is in the excretory system. Then what happens? At the end, normal. You see that when a person is having lack of water in the body's mechanism is to activate the ADH. The ADH, what it will do? It is seeing that more and more water is going out of the body through urine. It is being filtered. So what happens is, it goes and attacks here. Suppose this is ADH. Let's draw Savior. Superman. And Savior comes here. And Savior attacks on these kidney tubules. And the water that was leaking out, it was going like this and it was leaking out. Now, from the collecting tubules and from different places, of basically the kidney tubules, now water is being reabsorbed. H2O is being reabsorbed, so the amount of urine is decreased. H2O is being reabsorbed, and what happens is it is being given to the back to the body. It is given back to the body. Water is being absorbed, given back to the body, and less urine is being excreted. Got it? Now see here. Yes. You will say, sir is showing us cartoons and all these pictures. Oh my God, it's fun. We are making it fun for you. It is fun. Biology is fun and interesting. See here. Yes. Here you can also see how the water is being absorbed from the kidney tubules. And it is being done by Superman. Superman, oh my God. Here Superman is also there. Right. So this is actually Superman. For your body it's a Superman. It is as same as this Superman here. It's Superman. Why? Because if you have less water in your body, then you can have different problems, different diseases, different problems. So when your body is having low water content, this ADH helps to take in the blood. So is it not a lifesaver for you? Is it not a Superman for you? Superman is also a lifesaver. This is Superman. ADH is also Superman. Showers. So then we'll talk about disease. If this hormone is deficient, means less secretion of this hormone takes place, there is called diabetes insipidus. Sir, confusion. Diabetes mellitus, diabetes insipidus, both diabetes. What is the difference? Very simple. Let me tell you. You might be thinking, sir did not say anything. Reason is suspense. Before every great thing there should be suspense, and I try to keep the suspense. Now I am going to tell you what is the difference between diabetes mellitus and diabetes insipidus. Diabetes insipidus is due to deficiency of antidiuretic hormone. Antidiuretic hormone, as I said, is Superman. See that the body has low amount of water. So what it does, it goes, attacks the kidney tubules, as I said, and takes the water from it. And body gets back the water, and less urine is passed. There is less of urination. But if ADS is not there, what will happen? No control. So more and more urine will pass through the collecting duct. More and more urination will happen. Just like here you can see that ADH is helping the blood to come back to the body. It is taking back the body from the kidney tubules, increasing the reabsorption of the water. Reabsorption is very bhari term. Means it is taking the water back to the blood, back to the body. If this is less, that means there will be very less water reabsorption. There will not be that amount of water reabsorption that is required. And what will happen? More and more urine will pass. As more and more urine will pass, the person will have diabetes insipidus. Its problem is you will have frequent urination. Then sir, what is diabetes mellitus? I told you. If there is lack of insulin, or there is no insulin receptors, which you don't need to know, means if insulin is not there, is not able to work, then the amount of glucose in the body increases, in the blood. Free glucose in the blood increases, not stored as glycogen. Free glucose in the blood increases. So that glucose is filtered by the kidney, and once it goes filtration, we observe that the urine contains more and more sugar. Even we see when if a person with diabetes suddenly urinates on the floor, you will see ants go and ants gather around it. Why? Because that urine contains sugar, glucose. That is the difference between diabetes mellitus and diabetes insipidus. Did you understand? One is frequent urination, more and more urination, and one is having more and more amount of sugar in urine. This is glycosuria. This is the term. And this is polyuria. Frequent urination is polyuria. And more glucose in the urine, glycosuria. So we were talking about this only. Let me read it out a little bit so that you people have an idea. Diabetes means passing out excessive amounts of urine. The two types of diabetes are diabetes mellitus, the urine contains sugar caused due to insufficient insulin. Diabetes, the meaning of diabetes is meaning excessive amounts of passing excessive amounts of urine. So in both cases, in diabetes mellitus, in insipidus also, there is large amount of urine. There is no problem. But insipidus happens due to deficiency of ADH. And why does diabetes mellitus happen? Because there is more sugar or more glucose in the blood. Now what we are dealing is, what happens is, the urine in diabetes mellitus, the urine contains sugar due to insufficient insulin. But in diabetes insipidus, there is no sugar in insulin. Insipid means tasteless, blank, referring to the absence of sugar in urine, and melli means honey or sweet. So insipidus, this thing means that there is no taste of the urine. You don't want to taste urine, but for ants it's very tasty if you are a diabetes mellitus patient. And if you urinate on the floor, you don't urinate, you go to the bathroom and urinate. So the thing is, the insipidus means absence of sugar, absence. And mellitus means sugar, honey or sweet thing. Mellitus is a sweet thing. So your urine is sweet when it comes to diabetes mellitus, and your urine is having no sweetness. In case of diabetes insipidus, only frequent urination is there. Second thing, oxytocin. Now oxytocin is a very vital hormone, because in case of a pregnant mother, what is the main goal of a pregnant mother? You will understand when you will study reproductive physiology. I'll still tell you, you have known, even if you have a baby sister or brother, you will come to know that women or female face these problems. They have pregnancy, they become pregnant after some time, and the fetus is there in the mother's body. When the fetus is there in the mother's body, at one time when the fetus has developed enough, the uterus has to eject the baby out of the body. So to eject the baby out of the body, the uterus needs to contract. Now you can see the uterus here. If you see, uterus is this type of a cavity. I am not drawing the whole uterus. I am trying to show you. This is the uterus, this type of a cavity. And if here someone is placed, like a baby is placed here. I am just drawing anything. This is not a proper baby. This is a baby. What happens is, this has to contract. If there is no contraction, this baby won't come out of this place. You can see here the uterus. If this uterus, it is a muscular wall. So if they don't contract, then it cannot push the baby out of the body. You will understand this in detail when you study in reproductive physiology, but still I am telling you, this, if you see this uterus, this is small cavity, small place where the baby is there, the fetus is there, and it has grown to a proper level. Then what happens? Vigorous contraction is required, so the baby can come out of it, come out of the body. So this vigorous contraction is stimulated by the oxytocin. Oxytocin helps in the stimulus, vigorous contraction of the uterus like this. And finally, the baby comes out. You can see it here. See. You can see the uterus. You can see then a baby in the mother's womb. So these pictures will become more vital once you study the reproductive physiology that is there in your class 10 syllabus as well. And after this video, I will be showing you a place where we will show you a little bit of what happens in this context, how the baby comes out. So it will be shown to you in a brief video that will be shown to you later. So you need contraction. Contraction will help the baby to come out. So you contracting and the baby's, I'll try to make you understand through this diagram. Now a little bit of the baby comes out like this, because there is lot of contraction. Finally the baby comes out. This is the baby. I'm not drawing a very good diagram. This is the baby coming out. This you hear in hospitals. Now, generally, now normal delivery. This is the process of normal delivery that is not done nowadays. There are advanced procedures, but you don't need to learn. You learn it if you become a gynecologist. Means you are doing this type of a surgery. You just need to know the basics. So it helps in stimulates vigorous contraction of the uterus. It also stimulates milk ejection. What is milk ejection? From the mother there is a milk ejection that is there. That will be studying in detail in reproductive biology. So you will be aware that from the mother's breasts, milk gets ejected due to the stimulation of oxytocin. So oxytocin helps in the ejection, because after pregnancy the baby requires the mother's milk. So it is one of the hormones, oxytocin, that stimulates this milk ejection, and the mother feeds the baby with her using her breasts, and this is called breastfeeding also. So from the breasts the milk is being ejected. That is the thing. So it is also being one of the hormones. Oxytocin also stimulates this. So this was all about the posterior pituitary. I hope you are enjoying the lectures. I don't think you are disappointed. If you are enjoying the lectures, and if you can learn something from this lecture, learn one thing. You have to conceptualize the thing. You have to visualize the thing. And I am doing everything. Our team is doing everything to make you visualize the whole concept. Keep this. And you have to do the best in your exams. You have to make us proud. You are a student of this man. You are a student of our whole team is doing everything for you. So I don't want you to lose hope. You are the best. Remember this. And you will prosper. That is my word to you. Just keep viewing these video lectures. Repeatedly view them. You will forget. You will view. You will view. You forget. You forget. You view. Then after some time your mind will say, yes, now I'm ready to write any answer in biology. I'm the best. Right, you are the best. Bye bye. Have a great life. Thank you.
During a vaginal childbirth, the first stage of labor lasts about 12 to 19 hours. And starts when your baby settles lower into your pelvis. In response, your cervix begins to efface or become thinner and dilate or widen. During this time, you may feel strong, regular contractions occurring every 5 to 20 minutes and lower back pain and cramping that doesn't go away. You may see a brownish or reddish mucus discharge, which could be the mucus plug at the opening of your cervix, falling out. Your water may break, which can either be a large gush of fluid or a continuous trickle. If you experience any of these symptoms, contact your doctor or midwife to see if you should go to the hospital. At the beginning of stage 2 of labor, which usually lasts from 20 minutes to 2 hours, your cervix is fully dilated to 10 centimeters, and your baby's head has moved beyond the cervical opening into your birth canal. Your doctor or midwife will instruct you to push during your contractions and rest between them. In a normal delivery, your baby's head will rotate to face your back. During active labor, your uterus is divided into an active segment that contracts, pushing the baby downward, and a flexible passive segment that remains relaxed, stretching to provide more room for the baby to pass through. When the top of your baby's head appears, or crowns, your doctor may make a small cut, called an episiotomy, to enlarge the vaginal opening. Then, your doctor or midwife will give you instructions on how to push your baby out. As your baby's head passes through the birth canal, it molds into an elongated shape. An elongated head shape will resolve itself within a few days as the skull bones shift back into place. After your baby's head exits the birth canal, his or her head and shoulders will rotate to help the shoulders pass through the birth canal,